In this lecture, we will understand the basics of HCL, which is HashiCorp configuration language, and then create a resource using Terraform. Let us first understand the HCL syntax. The HCL file consists of blocks and arguments. A block is defined within curly braces, and it contains a set of arguments in key value pair format representing the configuration data. But what is a block, and what arguments does it contain? In its simplest form, a block in Terraform contains information about the infrastructure platform and a set of resources within that platform that we want to create. For example, let us consider a simple task. We want to create a file in the local system where Terraform is installed. To do this, first, let us create a directory called terraform-local-file under the /root directory. This is the directory under which we will create the HCL configuration file. Once we change into this new directory, we can create a configuration file called local.tf. And within this file, we can define a resource block like this. And inside the resource block, we specify the file name to be created as well as its contents using the block arguments. Let us break down the local.tf file to understand what each line means. The first element in this file is a block. Now this can be identified by the curly braces inside. The type of block we see here is called the resource block. And this can be identified by the keyword called resource in the beginning of the block. Following the keyword called resource, we have the declaration of the resource type that we want to create. This is a fixed value and depends on the provider where we want to create the resource. In this case, we have the resource type called local file. A resource type provides two bits of information. First is the provider, which is represented by the word before the underscore in the resource type. Here, we are making use of the local provider. The word following the underscore, which is file in this case, represents the type of resource. The next and final declaration in this resource block is the resource name. This is the logical name used to identify the resource, and it can be named anything. But in this case, we have called it pet, as the file we are creating contains information about pets. And within this block, and inside the curly braces, we define the arguments for resource which are written in key value pair format. These arguments are specific to the type of resource we are creating, which in this case is the local file. The first argument is the file name. To this, we assign the absolute path to the file we want to create. In this example, it is set to /root/pets.txt. Now we can also add some content to this file by making use of the content argument. To this, let us add the value "we love pets." The words file name and content are specific to the local file resource we want to create, and they cannot be changed. In other words, the resource type of local file expects that we provide the argument of file name and content. Each resource type has specific arguments that they expect. We will see more of that as we progress through the course. And that's it. We now have a complete HCL configuration file that we can use to create a file by the name of pets.txt. This file will be created in the /root directory, and it will contain a single line of data. The resource block that we see here is just one example of the configuration blocks used in HCL, but it is also a mandatory block needed to deploy a resource using Terraform. Here is an example of a resource file created for provisioning an AWS EC2 instance. The resource type is AWS_instance. We name the resource web server, and the arguments that we have used here is the AMI ID and the instance type. Here is another example of a resource file used to create an AWS S3 bucket. The resource type in this case is AWS underscore S3 underscore bucket. The resource name that we have chosen is data, and the arguments that we have provided is the bucket name and the ACL. A simple Terraform workflow consists of 4 steps. First, write the configuration file. Next, run the terraform init command. And after that, review the execution plan using the terraform plan command. Finally, once we are ready, apply the changes using the terraform apply command. With the configuration file ready, we can now create the file resource using the terraform commands as follows. First, run the terraform init command. This command will check the configuration file and initialize the working directory containing the .tf file. One of the first things that this command does is to understand that we are making use of the local provider based on the resource type declared in the resource block. It will then download the plugin to be able to work on the resources declared in the .tf file. From the output of this command, we can see that Terraform init has installed a plugin called local. Next, we are ready to create the resource. But before we do that, if you want to see the execution plan that will be carried out by Terraform, we can use the command terraform plan. This command will show the actions that will be carried out by Terraform to create the resource. Terraform knows that it has to create resources, and this is displayed in the output similar to a diff command in Git. The output has a plus symbol next to the local file type resource called pet. This includes all the arguments that we specified in the .tf file for creating the resource. But you'll also notice that some default or optional arguments which we did not specifically declare in the configuration file is also displayed on the screen. The plus symbol implies that the resource will be created. Now remember, this step will not create the infrastructure resource yet. This information is provided for the user to review and ensure that all the actions to be performed in this execution plan is desired. After the review, we can create the resource. And to do this, we will make use of the terraform apply command. This command will display the execution plan once again, and it will then ask the user to confirm by typing yes to proceed. Once we confirm, it will proceed with the creation of the resource, which in this case is a file. We can validate that the file was indeed created by running the cat command to view the file. We can also run the terraform show command within the configuration directory to see the details of the resource that we just created. This command inspects the state file and displays the resource details. We will learn more about this command and the state in a later lecture. So we have now created our first resource using Terraform. Before we end this section, let us go back and look at the configuration blocks in local.tf file. In this example, we used the resource type of local file and learned that the keyword before the underscore here is the provider name called local. But how do we know that? How do we know what resource types other than local file are available under the provider called local? And finally, how do we know what arguments are expected by the local file resource? Earlier, we mentioned that Terraform supports over 100 providers, including the local provider we have used in this example. Other common examples are AWS to deploy resources in Amazon AWS Cloud, Azure, GCP, Ali Cloud, etc. Each of these providers have a unique list of resources that can be created on that specific platform. And each resource can have a number of required or optional arguments that are needed to create that resource. And we can create as many resources of each type as needed. It is impossible to remember all of these options, and of course, we don't have to do that. Terraform documentation is extremely comprehensive, and it is the single source of truth that we need to follow. If we look up the local provider within the documentation, we can see that it only has one type of resource called the local file. Under the arguments section, we can see that there are several arguments that the resource block accepts, out of which only one is mandatory, the file name. The rest of the arguments are optional. That's it for this lecture.